So in this lesson, we're going to use the midpoint and the distance formulas. And a midpoint of a segment is the point that divides the segments into two congruent segments. Literally, it's the middle point. And these two little dashes right here mean the segments are congruent. So anytime we see that, we know that those segments are congruent, their lengths are the same. So here in our segment AB, M is the midpoint. Of segment AB. So segment AM is congruent to segment MB, and AM equals MB. And we remember that we have the two letters for the segment with nothing over top of them. That means the distance. So that's the midpoint. A segment bisector is a point, a line, a ray, a segment or plane that intersects a segment at its midpoint. Okay, so it is literally the thing that cuts a segment in half. So here we have line CD. This is the segment bisector of segment AB. So segment AM is congruent. Actually, let's write that a little lower so we can read it. Segment AM is congruent to segment MB, and AM equals MB. So the midpoint is the point in the middle of a segment. The segment bisector is the thing cutting that segment in half. And remember, a line cannot be cut in half because it goes forever in both directions, and half of infinity is still infinity. So let's, in fact, knowing what we just learned, pause the video and try this yourself. See what we come up with, then we'll go over it together. Okay, so in the figure, PM is 1.8, so we know that this is 1.8. We know that this PM is congruent to MQ, so that would make MQ 1.8. The segment bisector of PQ is going to be ray MT is the of segment PQ, and PQ equals PM plus MQ, and they're both 1.8 millimeters. So PQ is going to equal 3.6 millimeters. If that's what you get, you got, great job. If not, keep working. We'll have lots of chances to review. So once again, we got to identify the segment bisector of VW. So VW, that's this right here. So the segment bisector, just like in the last one, is right here. How do we know that? Oh, let's get red. We got our little dashes here, which tells us VM equals MW. So ray MT is the segment bisector of segment VW. Now we got to find VM. VM is this one right here. Okay, so VM equals 4x plus 1. So we need to solve for x. So to solve for x, we need x equals something. Well, we know VM equals MW because they're congruent. So we can use that. And then we just have an algebra equation. We get our x's on the same side. So we get x minus 1 equals 3. So x equals 4. We got to find VM. And we know VM equals 4x minus 1. We know x equals 4. So we can plug it in. And 4 times 4 is 16. Minus 1 is 15. So VM equals 15. And we are done. Let's do another one. Let's keep going. Same idea. So identify the segment bisector of AB. Well, AM and MB are congruent. We just identified that. So ray MT is the segment bisector of segment AB. We want to find AB, which is this whole big monster here. And we know AM is 3x minus 4, 2x plus 1 is MB. We know AB equals AM plus MB. So we got to find x. Well, AM equals MB. So 3x minus 4 equals 2x plus 1. Let's do our handy dandy algebra. X equals 5. So let's go ahead and plug it in. So we get 3x minus 4 plus 2x plus 1. So 3 times 5 minus 4 plus 2 times 5 plus 1. Yes, I could have combined like terms first, but I didn't. We'll get the same answer either way. So 3 times 5 is 15, minus 4 is 11, plus 2 times 5 is 10, is 21, plus 1 is 22. So AB equals 22. Or I could have plugged it into one side and doubled it. Or I could have combined my like terms and had 5x minus 3 equals AB. 5 times 5 is 25. Minus 3 is 22. A lot of different ways to get to exactly the same spot. All right, so given what we just did, pause the video, do this problem, and then we'll work through it together and see how you did. All right, so first thing, identify the segment bisector. Well, point M's our midpoint. We know that because we have PM congruent to MQ. L here is not talking about a point. There's no point there. There's no line crossing. It's lowercase. So line L is the segment bisector of segment PQ. And now we got to find MQ, which is this right here. Well, we have two congruent segments. We have formulas for, so we can go PM equals MQ. 5x minus 3 equals 11 minus 2x. Get the x's on the same side. Let's make that a little neater. 7x equals 14. So x equals 2. We got to find MQ. MQ equals 11 minus 2x. X is 2, so 11 minus 2 times 2, which is 4. So MQ equals 7. And if you got 7, great job. Let's do one more example, and we'll move on to something different. So we'll work together on this one. Identify the segment bisector of RS. Once again, we have congruent segments. So therefore, RM equals MS. We can solve for x. So 4x plus 3 equals 6x minus 12. We're going to get the x's on the same side. Then we're going to get the x by itself. Divide by 2, so x equals 7.5. This time we want to find RS, which is the whole thing. So RS equals our segment addition postulate, or RM, plus MS. So we got 4x plus 3 plus 6x minus 12. This time I am going to combine like terms before I do anything else. So I get 10x. 3 positive 3 minus 12 is negative 9. 10 times 7.5 minus 9. So 75 minus 9 is 66. And we are done. And the next video we'll pick up with the midpoint formula.